So today I'm gonna try to solve the Polygon area calculator from free code camp. I haven't looked at the problem yet. So this is the first time that I'm looking at it. This project you will use object-oriented programming to create a rectangle class and a square class. The square class should be a subclass of rectangle inherits methods and attributes. So the square is the subclass of rectangle class. When a rectangle object is created, it should be initialized with width and height attributes. The class should also contain the following methods: set width, set height, get area, turns width, times height, get perimeter. So I looked at this later. I assume this is the main file where they want to run, just like the other ones. And here I'm supposed to change things. Additionally, if the instance of a rectangle is represented as a string, it should look like rectangle width. So there's going to be a string method, just like the other one. Self, I think. I'm not sure if it's going to ask for a name. And from the video I saw from the Faraday Academy, I think doing like this is okay as well. I'm not quite sure. If it doesn't work, I'm just going to put a string here. Let's see if it gives me any errors. Yeah, apparently it's not working. Let me see her video again.
I guess figure out the percentage.
It's a little bit before this.
I don't know. Let me just. But then I don't know. So let me. I only failed 2 out of 11 tests. That's pretty good.
It's a little bit before.
On here. Yeah. Clothing dot withdraw.
So here she did like this. For some reason, no, it's not working. Maybe I did the spacing wrong. It's kind of hard to see with the show. That doesn't work. Maybe it works, but it's just Replit giving me an error for no reason. Or maybe it doesn't take name as an argument. So and here there's a space. Nope. Well, let's return something and see. Yeah, it's still not working. Yeah, anyway, let me keep reading. I'll look at this later. Set width and set height methods on the class should set both width and height. Development. Write your code in shape calculator. For development, you can use main.py to test your shape calculator function. Click the run button and main.py will run testing. Okay. So it's pretty much just create these 2 classes. It should be initialized with width and height attributes. So Saf self, width, and height. Self dot width. That's pretty much it. No, the class should also contain the following methods. Oh, now it works. It stopped showing me an error. So I guess it was just because it didn't have anything on the init. So these are the methods that he wants me to put there. It's 1, 2, 3, 4, 5, 6, 7, including the picture or no? Oh, anyway. So I set width is the first one. Height, get area, get perimeter. Get diagonal. Get picture. Get amount inside. Additionally, if an instance of a rectangle is represented as a string, it should look like this. I think that's easy to do, probably. Just return. That should be an F here. Then if equals true. Now I'm not sure if I can call. I don't remember really well. I think it's self dot set that self dot. Yeah, I don't have a method for. Maybe just self dot width. And then height equals true. Self dot height. Square class. The square class should be a subclass of rectangle. When a square object is created, a single side length is passed in. The init method should store the side length in both the width and height attributes from the rectangle class. The square class should be able to access the rectangle class methods, but should also contain a set side method. So I'm not really sure how to make subclasses yet. I'll look at this later. I think I'm gonna try to do this first. So they don't have an explanation of exactly what they want, but I think it's intuitive. This should set the width. So yeah, I forgot to put the self here. And I think here they have an example how it's going to be used. So it gives two arguments, self and width and height, which becomes the width and height of the rectangle. Get area doesn't have any arguments. Set height has an argument height, I think width It's gonna have the argument with. I think this can be anything as well. It doesn't have to be this name. I'm just writing like this because it's more intuitive. Get parameter, no argument. Get diagonal, no argument. Get picture, no argument. Get mount inside. Get mount as an argument. So now I have to think about. I think it's pretty simple. Just do the same thing again. Maybe I should call it other names so it doesn't get confusing. And I don't think it needs to return anything. I put new with here just so I don't get confused. Returns area with times height. I think that's it. Get parameter returns oh, 2 times plus. I wonder if I can put in brackets with plus height and then just make it equals true. 2 times plus. Seems to work. There must be something wrong with this because it can't be this easy as well. Or it's more challenging later, probably. So this is a little more. I think it's the same code as before. And I'll put this in parentheses. And I think this works. Returns a string that represents the shape using line of the number of lines should be equal to the height, the number of asterisks. I'm not sure how to say this in English. In each line should be equal to the width. There should be a new line at the end of each line. So this is where it gets difficult for me. So the number of lines should be equal to the height. So I can do. I'm not sure if I can do this inside of the thing. should be equal to the height, so I'm self dot height. I have to think about it if the way that I'm thinking is gonna reproduce what they want. The number of this symbol should each line should be equal to the width. I think I have to escape it because this is a special character. Forgot how they did it on the previous one. I think it was something like this. So not width. There should be a new line at the end of each line. So I think this comes first. So the way that I'm thinking this is gonna work, but I'm not sure, is that this is gonna create this symbol as long as the width of the rectangle, and then it's gonna create a new line. But maybe this new line has to be outside of this. Now that I think about it, because I want it to be this, then the new line, then multiplies this by the height. Let me see on her video. Yeah, that's how they did it. But I think this puts on the center. I'll have to check later. I'll type it like that, and then I'm gonna search for it. Or maybe if I don't put self.name, I just put the symbol, then it works. Yeah, I think I did this slightly wrong there. Yeah, I'm not sure if this works. We'll see. Probably doesn't. It should be a new line at the end of each line. If the width or height is larger than 50, this should return the string too big for a picture. So width self.width is bigger and 50. Get amount inside. Takes another shape, square or rectangle as an argument. I can put shape here instead. Returns the number of times the past in shape could fit inside the shape with no rotations. For instance, a rectangle with a width of 4 and a height of 8 could fit in two squares with sides of 4. Yeah, this one's more difficult because I have to think about math. Turns the number of times the past in shape could fit inside the shape with no rotations. So it's gonna accept either of them. The problem is if I have two, yeah, if I have one rectangle and then it passes a square, I have to figure it out if it's not gonna be the same logic as if I have two squares. Maybe they want the opposite one because it would be infinite the amount of times. Because I can always slice it up more. Yes, I think that's what they mean. So when you have a square and you put another shape, how many times it will fit? And it doesn't matter the order because it's always going to be a square. Oh, well, it can be a square instead of rectangle. Maybe that's not what they mean because even in square inside of a rectangle, you can go to infinity. Oh, the past in shape could fit inside the shape. No rotations. Yeah, so the shape itself is gonna be passed as the dimensions predefined. Yeah, so maybe it can be two squares, two rectangles, or square in a rectangle or a rectangle in square. Rectangle with a width of 4 and a height of 8 would fit in two squares with sides of 4. Additionally, if the instance of rectangles represents the square class, the square class should be a subclass of rectangle when a square object is created, a single side length is passed in. I think I'm gonna do this first. This get amount seems to be the hardest one. The init method should store init method should store the side length in both the width and height attributes from the rectangle class. I think I can do this by using super. I think I saw this on previous video when I was doing the previous challenge. First, let me search about the length. How can I search about this? I wanna find the site that it's not this one. I think it was this one. No. So I guess this is the way. I'll copy this just in case. I also see a problem now with this, is that this should be outside. I'm not sure if I can do this. Maybe it works. I can also do a loop outside. It's easier to multiply by the height directly. Yeah, so this is the thing. I put a 0 here. Now I'm gonna look at classes. Oh, actually, I have to look. I guess just put in parentheses and multiply. So instead of doing like this, because I'm not sure if it's gonna work or not, just gonna do it this way. Oh, okay. I think this is better. I mean, it has to return, I think. I guess. I'm gonna put a new name here, just so it's not confusing. Now let's look at the how to make a subclass.
Hey everybody, how's it going? In this video, we'll be learning about Python class inheritance. Now, just like it sounds, inheritance allows us to inherit attributes and methods from a parent class. Now, this is useful because we can create subclasses and get all of the functionality of our parent class, and then we can overwrite or add completely new functionality without affecting the parent class in any way. So let's go ahead and look at an example of
Oh,
this.
I just realized how to do this. You gotta mount inside. I think what I have to do is first get get the area of this one, and then I need to calculate the area of the other one, and then I divide them. and take the remainder, take the full number. I think that's so. Area soft dot get learn area. It is also suggestion thing. So first I get the area of the one that is measuring, then I make shape dot get area, and I assume this area is gonna be shape area. This area is gonna be bigger than this one always. So if shape area is bigger than area, return 0. Else, then I divide area by shape area. I want to think about, because it might be a broken number, so I want to get the exact portion of this. And I know there is a way to yeah, this is always going to be a rectangle. Or it's gonna, maybe it's gonna have this method on both classes, since this one is gonna inherit the classes from this one. The remainder I know that is a percentage sign, but how can I say this? I'm not sure if this is gonna give me anything. I think I'm gonna search for division methods. Yeah, so this is the way. I'm actually gonna put here. So I think this gets the full number. And it should be how many times one shape fits into the other one. If it's bigger than the area of this one, then you return 0 because it's bigger. But maybe they want it either way. So it doesn't matter if it's bigger or not. They just wanna See how many times one fits into the other one. Takes the shape as an argument, returns the number of times the passed in shape could fit inside. Yeah, so they want the shape that is passed to see how many times the shape that is passed fits inside the shape that of the class. I hope this works. I'm not quite sure.
And we'll see why this is useful. So for our object-oriented video so far, we've been working with this employee class. Now let's say that we wanted to get a little more specific here and create different types of employees. So for example, let's say that we wanted to create developers and managers. Now these would be good candidates for subclasses because both developers and managers are going to have names, email addresses, and a salary. And those are all things that our employee class already has. So instead of copying all this code into our developer and manager subclasses, we can just reuse that code by inheriting from employee. So let's go ahead and create these developer and manager subclasses. And it's just as easy as creating a new class, just like we did up here with employee, but we're going to call this new class developer. And after the name of the class, we can put these parentheses here and specify what classes that we want to inherit from. So in this case, we want to inherit from the employee class. Now, I'm just going to put in this pass statement here for now because I want to show you that by simply inheriting from that employee class that we inherited all of its functionality. So right now, even without any code of its own, the developer class will have all of the attributes and methods of our employee class. So right now, down here I have two instances of our employee class, and then I'm printing out both of their emails. So if I save this and run it, you can see that when we create two new employees and print out their emails, that we get this result. So now, instead of creating two new employees, I'm now going to create two new developers and pass in all of the same information. So now, if I rerun this and print out those emails, you can see that those two developers were created successfully and that we can access the attributes that were actually set in our parent employee class. So what happened here is that when we instantiated our developers, it first looked in our developer class for our init method, and it's not going to find it within our developer class because it's currently empty. So what Python is going to do then is walk up this chain of inheritance until it finds what it's looking for. Now this chain is called the method resolution order. Now I want to show you this really useful function here that makes these things a lot easier to visualize, and that is the help function. So first I'm going to copy out these two lines here, and then I'm just going to print out this help function,
Forgot to
and
change
I'm going
the
to pass
name of
in the
string.
developer class. So if I go ahead and run that, and I'm going to make this a little bit bigger here. Now you can see that when we run help on that developer class, that we get all kinds of good information here. So that method resolution order that I mentioned is one of the first things that gets printed out. And basically, these are the places that Python searches for attributes and methods. So when we created our two new developers here, it first looked in our developer class for the init method. And when it didn't find it there, then it went up to the employee class and it found it there. So that's where it was executed. Now, if it hadn't found it in our employee class, then the last place that it would have looked is this object class. And every class in Python inherits from this base object. Now, if we look at this output further, then it actually shows the methods that were inherited from employee. So you can see here that we have the init method, and we also have our apply raise method and our full name method. And if I keep scrolling down here, then you can also see that we have our data and other attributes, and you can see that the class attribute raise amount was also inherited from the employee class. So we got all of this code for free just by inheriting from that employee class. Okay, so now I'm going to go ahead and make this smaller again, and
Well, I'll try to write it the way that I think it is, and I'm gonna look at the video. It should be a subclass of rectangle. And a square object is created. A single side length is passed. Then I think it's like this super, and then I get the methods that I want to get. The init method should store the side length in both the width and height attributes from the rectangle class. Yeah, so I would do it like this. Apparently it doesn't work. So maybe it's like this.
And I'm going to take out that printed help statement. Okay, so now let's say that we wanted to customize our subclass a little bit. I'm going to make a very simple one-line change in here, and I'm just going to change the raise amount. But first, let's go ahead and see what happens when we apply a raise on our current developer. So I'm going to print out, this should actually be pay, and this should be pay. Now I'm going to print out our current developer's pay here, which should be 50,000. Then I'm going to apply a raise, and it should find our employee's raise amount of 4%. And then I'm going to reprint out that developer's pay again. So if I save that and run it, you can see that it printed out 50,000, applied the raise, and then printed out 4% higher. But let's say that we wanted our developers to have a raise amount of 10%. Now to change that, it's just as easy as coming into our developer class here and just changing the raise amount to 10%. So now if I go ahead and rerun this, and our parent class can handle. So what do I mean by that? So let's say that when we created our developers here, that we wanted to also pass in their main programming language as an attribute. But currently, our employee class only accepts first name, last name, and pay. So if we also wanted to pass in a programming language there, then to get around this, we're going to have to give the developer class its own init method. So what I'm going to do is I'm just going to go up here to our employee class and grab that init method, and I'm going to paste it here within the developer class. Now, along with the first name, last name, and pay, I'm also going to add in an argument here for the programming language. Now, what you might be tempted to do here is just go up and copy all of this code from our employees class's init method and paste it into our developer class's init method. But we don't want to do that because we want to keep our code dry and not repeat this logic in multiple places because we want it to be as maintainable as possible. So instead of copying and pasting that, what we're instead going to do is just let our employees init method handle the first name, last name, and pay, and then we'll let the developer set the programming language. So in order to let that employee handle the first name, last name, and pay, what we can do here is just do super.init, and then we can pass in the first, last, and pay. So again, super.init is going to pass first, last, and pay to our employees init method and let that class handle those arguments. Now, there's multiple ways of doing this logic here. You may have seen some people do employee.init, and instead of passing in first, last, and pay, they'll type in self and then first, last, and pay. Now, both of these ways of calling the parent's init method will work, but I tend to use super because with single inheritance like we are using here, it's a little bit more maintainable, but it's really necessary once you start using multiple inheritance.
So I also have to put. Well, I'm not sure where I should put this thing. There's argument here. If it's on rectangle or square. So I need to put width and height here.
Inheritance. And we're going to go over that in a future video. But to keep things simple, I usually just like to always stick with super. So now that we're letting our employee class's init method handle the first, last, and pay, now we can handle the programming language argument just like we would in any other class. So I can just say self.programming language equals the programming language that we passed in here. Okay.
I think it's going to be here. Makes more sense. Because this is the subclass. So if this is the parent class, it doesn't make sense every time I want to create a subclass to add one more thing. No, why this is showing me that's wrong. Oh, typed the wrong way here.
And that should be all we need for our init method. So now when we instantiate our developers down here, it's also going to be expecting a programming language to be passed in. So I'm just going to go ahead and pass in Python for our first developer, and I'll pass in Java for our second developer. So now to make sure that this worked, I'm going to comment out those lines there, and I'm going to print out the first developer's email, and I'm also going to print out the first developer's programming language. Okay, so if I run that, then you can see that both of those were set correctly. So we got the email set by it when we passed in all of our arguments here. It came up here and it ran our employees init method and set all of those within there. And then it also set our programming language within our developers init method there. So you can see why this subclassing is useful because we were able to customize just a little bit of code, and we we got all of this code from our employee class for free just by adding in that one little line there. Okay, so just so we can get a really good understanding of this, let's go through the process of creating another subclass called manager, and I'll go through all these steps again, but I'll go a little bit faster this time. Okay, so right here below our developer, I'm going to create another class, and I'm going to call this class manager, and this is also going to inherit from employee. Now, when I create a new manager, I'm going to give the option of passing in a list of employees that this manager supervises. So we're going to need to add an init method for our manager, and instead of typing all this in, I'm just going to grab this init method here from our developer and paste this in here. Okay, but this is going to be a little bit different. Instead of a programming language, for our manager, I'm going to let them pass in a list of employees, and I'm going to set the default to none. And then instead of setting this programming language here, I'm going to say if employees is none, self.employees is equal to an empty list, and then else self.employees equals employees. Now, you might be wondering why I didn't just pass in an empty list as the default argument here instead of none, but you never want to pass mutable data types like a list or a dictionary as default arguments.
I don't understand though if it's gonna require me to put the 3 arguments instead of only the side to create a square.
That's a topic for another video, and I plan on doing
square.
one on that soon. But for now, we'll just go ahead and set our employees to an empty list if the argument is not provided, and set them equal to that employees list if it is. Okay, so now let's add in a few methods here. So I'm going to give the option to add and remove from our list of employees that our manager supervises. And to do this, I'll add in a method called add employee, and add employee will take self, just like all of our instance methods do, and employee. And then I'll just say if the employee is not in self.employees, then I will just append that employee to our list. So self.employees.append that employee. And now I'm also going to create another method here to remove employees from this list. And it's going to be similar. So I'm just going to go ahead and copy that list and to print out all the employees from that list. So now let's see if this works. So I'm just going to email address. So now if I save that and run it, how useful this actually is, because all of the code in here is specific to what we want for a manager. And in our developer class, it's specific to what we want for a
So what's going on, guys? In today's tutorial, we're going to be talking about inheritance, still on the object-oriented programming series with Python. I think it should be the 4th video, and we're going to be talking about inheritance. Now, just as inheritance sounds, inheritance allows us to actually inherit attributes and methods from a parent class through subclasses. Now, that might sound weird to you, so I'm just going to explain a little bit. So I'm going to create a new file on here, and I'm just going to save it as a class. So let's just call it whatever, that's pi. I'm just using this class to illustrate a bit. So if we wanted to create, let's say, an application for a school, and we're trying to create a model, and we're trying to create a student class, just as we have done, we've defined the initialization for that class, which is self, the first name, the last name, and the age of the student. We can go ahead and say self the first name. Self the first name is equal to first name, self dot last name is equal to last name, self dot age is equal to age, and so on. And this class might have a bunch of functions, say a function like full name, to go ahead and take the self, and then it's going to return self dot first name plus a space. Let's give that space, and self dot last name, that's a basic function. And then we can have another class in this school that's going to take care of the teacher, so that is a teacher, and we still have to go and def init add init to underscore. So self first name last name and the age of that teacher, and we can still go ahead and initialize it this way instead of typing that out. You can see. And what if we had another one here? Let's say for non-academic workers, so we can say non-academic, so non-academic staff or whatever. So that is that, and we can still go ahead and have an init. And if you're looking at these classes, you can see a recurrence or some basic common features. We have last name, I've got age, and we'll still go ahead and actually initialize this. Okay. So how do we make our code much more cleaner than what we're seeing here? Because in good codes, we want to keep it dry. That is, don't repeat yourself when you're coding. Now, as you can see in this class, they commonly have first name, a last name, and an age. Okay, so we can take that as something they have in common. Now, when we talk about inheritance, it is like an is-a relationship with a bunch of attributes. So we can say a teacher is a person, like right? Yeah, a student is a person. A non-academic staff is also a person. So a person has a first name, a last name, and an age. Every human has that. So you can see that the attributes are these, and every person might have a full name. Yes, everybody has a full name. So this function can actually be referred to that of a person. So what can we do to make this a bit simple? So I'm going to go back to the other file which we created. We've done a lot of stuff here, including class methods and static methods. So I'm not going to touch that for now. What I'm going to do is I'm going to go ahead. Let me remove this date time. Because date time, I don't think we'll be needing the get current time for now. Okay, we're okay this way. So instead of actually creating these other classes with this bunch of extra attributes, say self, the first name, last name, and so on, we could go ahead and create a class, say person. So the class is person, and that person will have all those attributes. So we're going to give an init, and it's going to take self. So it's going to take the first name of the person, the last name, and the age of that person. Okay, so we're going to give the normal, say self, the first name is equal to first name, self, that's last name is equal to last name, self, the age is equal to age. So have that prototype out here. So how can we be able to reuse all these features in the student class? And that is very simple. When creating the student class, we're going to give an open and close parenthesis, and we're going to give this person right here, which means this student is a person, or it's here is a subclass of person. Now the student is going to be a subclass of this superclass or superclass here person. So once you do that, you can see that the student has basically inherited from the person, and it still has its own attributes and still has its own functions. Now what I'm going to do is I'm going to strip down this function full name. I'm going to remove it from here, and we're going to add it to the person, because this function can be accessed by any person, be it the teacher, the student, or a non-academic staff. Okay, so we've got this full name, which basically what it does is it returns self dot first name, which we've declared, and self dot last name concatenated with a space. Okay, so as you can see, that's what it does. Now we've got this extra bunch of code which basically just redoes what this function is doing. So what we are going to do, I'm going to remove this full name property here. So instead of saying self the first name is equals first name here, we're going to do something. Okay, so as you can see, we inherited from the superclass person. Okay, now student is a subclass of the superclass person, which means we can actually access this init method of the person. Now there's a special keyword in Python for doing that. Now we're going to say super open and close parenthesis dot underscore underscore init underscore underscore, and we're going to pass in these two parameters. Okay, first name and last name, and let's also collect the age of the person. So collect the age. So we're going to say first name, last name, and age. So this basically what it does is it's going to initialize this class, the student class, with these parameters, but it's going to use the superclass, that is this class over here. So other people might do it this way. They might say call the class itself, so person dot underscore init, then we can give self, first name, last name, and age. But I personally prefer using the super. So this is also very useful when you start getting into multiple inheritance. So it's a good idea to stick with the super in your programming day. So okay, so basically got that out there, and we're going to test
I think this is it. Self with right side. Square class should be able to access the rectangle class method, but should also contain a set side method. So I'm not sure if this makes it access all the methods automatically, but I'm gonna assume it does. I always forget the self new size. If the instance of a square is represented as a string, it should look like square side 9, side equal 9. True, right, true. Additionally, the set width and set height methods on the square class should set both the width and the height. So this is a little bit tricky because I'm not sure if I can just write them again or if there's something that I need to do to make sure.
This actually works. Okay, so I'm going to remove this, get call time, and we have 3 basic students which we've created in the previous tutorial. Okay, like you can see now we created the students with the first name and the last name, and we need an age, so we're going to give some age. So this person is 19, this is 18, and this is 15. So I can go ahead and try to print student 1 dot full name. Now you can see this function is not directly accessible from the student's class. It's actually in the person's class. So let's see if we can access that. So once I run this, you'll see that actually gives us a full name. Like that's very great. Okay, and let's try to say we create stud1 dot first name. Okay, and let's see what we get. And once I contribute on that, wow, that is working fine. So I'm going to go ahead and create let me remove this. I'm going to go ahead to create a new class. Say this is going to be a teacher class, and we're going to call def underscore init. Now before we initialize this, we have a basic pay here, which is the pay of the teacher. I'm going to put 5,000 for now. Okay, so def init. We're going to take self, and I think we're going to take the first name. We're going to take the last name and the age of that teacher. And we forgot to inherit the teacher from the person, so I'm going to go ahead from here and give that to be a person. Okay, right? Okay, so we could go ahead and say super here dot underscore init. Then we're going to give no need for self, so first name, last name, age, and that will do it. So that is how to initialize that. And we want to actually give this teacher a bunch of students with the teacher handles. Okay, so we could say studs, that's a student. The handles is going to be none. Okay, so you don't want to give that as an empty list. Let's just leave that as a none. So here we're going to give if studs, that's a student handles. If studs is equal to none, then we're going to say self.studs is equal to an empty list. Okay, and then else self.studs is equal to studs, that is this here. Now this studs should be a list of students the teacher is going to be handling. Normally in a real world model you might actually want to do this by their classes, that's grade 1, grade 2, and so on. But in this case, I'm just taking this as the teacher just handles a bunch of students. So I'm directly passing the students the teacher handles directly to the students. Now you can see this class actually has its own special functions. Now we're going to define a few functions. Say add students. That's for adding a new student. We're going to give a self and the student. Now we're going to say if the new student, that's stud, if the student not in self dot studs. That's if the student is not in the list of students that this teacher is going to have. Then we're going to say self.studs.append. Can't type, so it's going to append the new students that was passed. Okay, then we're going to define another function, remove stud, and it's going to take self and same as stud. So if stud in self.studs, so what we're going to do is we're going to say self.studs.remove the students that were passed in, and then the final function is going to be show students. This is going to show all the students the teacher is handling. Okay, so show. Then for now, final teacher. So teacher 2 is going to be teaching.
What's up, you guys? Welcome back to another Code with Kylie video. I'm Kylie and I'm still filming from the floor today because I still am part of No Desk Squad. Anyways, we're talking about inheritance and polymorphism. These are big words, but I promise you that they're actually very helpful concepts in object-oriented programming that will help you make your code more concise and more flexible. So let's just dive right into it. I'm going to initialize them. Of course, we have to add self in there. And let's say for simplicity, we're just going to give all these dogs a name. So self.name equals name. And this is going to go through all of these like this. Right off the bat, you can see that we have the same initialization function literally copy and pasted 3 times. In addition, if we had another function like likes walks. And of course, all of our doggos like walkos, so we are going to paste these everywhere. So what we're seeing here is a lot of code repetition because these 2 functions are basically copy and pasted for all 3 of these dogs. If we take a step back and we think about this in real life, well, Samoyeds, poodles, and golden retrievers, they're all a breed of dog. So what we can do in Python is we can actually add a parent class to all of these classes, which unifies them as that type of object. We can create a superclass called dog, which basically would have all the properties and functions of a dog to share among all of the breeds. So here we can say init, and then we can give it even other things like age, friendliness, etc. And here, let's do self.name equals name, self.age. We're just initializing all of these attributes within our class. All the doggos like the wackos, so we're doing likes walks, self. And this is true. Okay, so now that we have the superclass, remember what we said about how inheritance basically allows the child class to inherit from the parent class? All we would have to do is classify our 3 breeds as child classes of dog. And how do we do that? Here in our class definition, all we have to add is parentheses, and then within the parentheses, the parent. So here we have Samoyed, and then this basically means Samoyed is a child class of dog. And here we can even erase this. And of course, we would input the name, age, and friendliness. But then down here, instead of reinitializing the exact same thing, we don't have to copy and paste that code. Instead, we can just do super, and this means call the superclass dot init. So here this is saying in the superclass, call this initialization function, and then we're going to pass in the parameters that belong up here. So that's name, age, and friendliness. And then I'm going to do that with.
Let me run this and see how many I'm getting wrong. Line 12. I don't think I'm gonna be able to continue if I don't finish the square class. Need missing true, required positional argument, side, height, and sign. Maybe I should put the default to 0. think this is the problem here. I think you can't find the area because it's requiring height and size.
Pull my doggos down here and change these so that they are now subclasses of dog. Ta-da! All right, so let me just show you guys how this works. You can see that in Samoyed, we haven't defined likes walks, but if I create Sammy the Samoyed and I pass in a name, so Sammy, an age, 2 maybe, and then friendliness, let's do a scale 1 to 10, let's say 10. Let's say that Sammy is 10 out of 10 friendly. Okay, so now what we can do is we can print Sammy.name, Sammy.age, and Sammy.friendliness. Okay, so we see that for Sammy, we get that the name is Sammy, the age is 2, and Sammy's friendliness is a 10 out of 10. So here, this initialization function has actually called this one up here to set the attributes. Okay, so one other cool thing is we can actually print Sammy.likeswalks. And again, we haven't actually defined likeswalks as a method under Samoyed, but we have in the superclass. And now you can see that it will actually inherit from that superclass, so we can actually call this function likeswalks. Okay, so look, it's true. And just like in real life, we can also have mixes of these dogs, which would mean that we have more than one parent. So this is something called multiple inheritance, where you can have more than one superclass. And the child class would actually inherit all the properties and attributes of all the parent classes. So here, if I want to create a golden doodle, maybe, then I can say golden doodle, and this is going to inherit from poodle and golden retriever. And of course, we initialize this, just like how we initialize these other things. Let's call this golden doodle Goldie. Goldie the golden doodle. And Goldie, age, let's do 1. And friendliness, man, 10 out of 10, of course. We can print these things again. And we see that Goldie is age 1, friendliness 10 out of 10, and likes walks. All right, so one reason that we might want to define golden doodle with poodle and golden retriever as separate classes is because maybe poodles and golden retrievers both have properties that we actually want to pass down into this golden doodle. So for example, our shedding amount. Well, poodles don't shed, so here we're going to return 0. And then for golden retriever, let's do one that's like define fetch ability. And this is a method. So let's say the self.age is less than 2. Maybe the golden retriever is not that great at fetching yet, so we'll give it an 8 out of 10. So return 8. But let's say else if the age is less than 10, so this is maybe something between 2 and 10, we can return 10 out of 10. And then otherwise, which means that it would actually be older than 10, we can return 7.
Just not gonna talk about it.
A bit about polymorphism. Now, what in the world does polymorphism mean? Polymorphism quite literally means the ability to take multiple forms. From an object-oriented standpoint, this actually means that a child class that inherits a function from maybe the parent class can override that function and give that function a completely new set of rules to follow. So again, let's do an example with our dogs. Under our dog, maybe we can define our bark. All dogs might bark like woof. So we can return woof as our bark for all of our dogs. And that's just our default bark. Okay, so we have Sammy and we have Goldie. Let's just see what their bark would sound like. Okay, so we're printing Goldie's bark and Sammy's bark. And both of them are woof. But we can actually change this for subclasses and make the subclass follow a different set of rules. Come down here and I define bark. This is polymorphism because we can actually override this and we can say arf arf maybe. Whereas maybe a golden doodle is saying something like...
So it's just as simple as writing. So which ones do I need? Addition is the set width and set height methods of the square class should set both width and height. The set width methods on the square class should set both. So I guess what they mean is that I need to set both of them each time. Like this maybe. Is this what they mean? This ensure required position arguments, height and size. And side. But why is asking this from the parent class? Square 9. It's calling this square. Oh, maybe that's the problem, I think. Oh, but that doesn't make sense actually. Scratch that. Do you understand why it's not working if the videos are exactly like this? Square object has no attribute with. Yeah, I know the problem is on initializing this. So I think what's happening is that it's only giving me one value, and because I have width, height, and size, it imagines that the width is equal to the value that is giving, and then it misses these two arguments here. So maybe it should be the other way around here. Maybe this works. Yeah, but all the videos show it like this.
Aru or something, I don't know.
Softening. Is it correct here?
Now let's listen to these dog sparks again. And just for comparison, I'm going to create a new dog object. Generic doggo equals dog, and I'm going to name it Gene. It's going to be 10 years old, and of course it's 10 out of 10, a good boy. So we're going to also say this generic doggo dot bark. Okay, so we're doing Goldie, Sammy, and then generic doggo. So we see that Goldie is now barking like a roo, but then
Maybe we should put side here. That doesn't make too much sense. From what I understand so far, the super method gets the attributes from the parent class. Yeah.
Sammy does arf arf, and this generic doggo goes woof. This
In the next few minutes, I'm going to explain the Python keyword super. Let's jump straight to an example. Here we have a base class, which prints base.init, and we have a child class, child1, which inherits directly from base. On instantiation of this child class, we're directly calling a method from the base class. In addition, we print child1.underInit. Let's create an instance of child1 to see what happens. We see the behavior that we expect. We called the dunderInit method of the base class, and that prints base.dunderInit. We then printed child1.dunderInit. No surprises there. The problem arises when multiple inheritance is used. We've added a second child class, almost identical to the first. It too is representing a case where there needs to be some form of initialization from the parent class. Child 3 has both child 1 and 2 as its parents. It inherits from both. In its dunderInit method, it calls initialization from child 1 and 2, and then it prints child3.dunderInit. As we can see, after creating an instance of child 3, the problem is that base.dunderInit has been called twice. This isn't a problem here, apart from looking unsightly, but this could cause lots of problems for you in your code unless you practice the utmost diligence, and even then, it could bite you. On the other hand, when we change this to super, we call super with an added bonus that we don't need to pass in the instance as an argument. It now works perfectly. For every class that you define, there's a method resolution order that Python computes. It's essentially all the base classes in a linear order. The MRO, the method resolution order, is calculated using a technique known as C3 linearization, which is a merge sort of the MROs from the parent classes subject to 3 constraints. 1. Child classes get checked before parents. 2. Multiple parents get checked in the order listed, and 3, if there are 2 valid choices for the next class, the one from the first parent is chosen. When Python sees super, it continues its search starting with the next class on the MRO. As long as every redefined method consistently uses super and only calls it once, the entire MRO list will be worked through and each method will only be called once. That's why in our altered example, base is only called once. Also, base is followed by child 2 and then child 1. As you can see, that's because the MRO has from left to right child 3, child 1, and then child 2, finally followed by base and object. So child 3 is last to be called, and it's the leftmost on the MRO list. So base being rightmost, ignoring object, the base dunderInit is called first.
Pretty much the same thing that the other ones were saying. So it should be the other way around. Now it's telling me that it's missing true arguments. Oh, it's not. That should be like this.
What's sometimes difficult to grasp at first is that super doesn't necessarily go to the direct parent of a class next in the MRO. You can even use it in a class with no direct parent at all, as we'll see in our next example. Here we have a somewhat deficient adder method in both a 10 class and a 100 class. Each adder method takes in an arbitrary number of positional arguments and then prints the sum of those arguments plus 10 in class 10 and plus 100 in class 100. What's more, class 10 has a super call after the print statement. The experiment class inherits from class 10 and class 100. We create an instance of experiment and then we call inherited method adder, passing in arguments 1, 2, and 3. What's
I should take this off.
Hello everyone, how are you doing today? Welcome to the video series on interesting topics of modern Python programming. And in this video, I'm going to talk about multiple inheritance in Python with respect to a single function that is called __init __. You might be wondering that why I'm dedicating complete video on this one function.
I'm gonna go to the bathroom real quick.
I believe by the end of this video, you will get your answer. So this is the second video on inheritance. If you haven't yet seen my first video on inheritance, I will highly recommend you to go ahead and see this card, okay? Now let's go ahead and understand multiple inheritance with respect to init function, okay? So we all know why we use inheritance, for reusability purpose. Now before I go ahead, just one suggestion from a programmer to the programmers. Before using multiple inheritance, just try to understand and try to judge the situation and come to a conclusion whether you really need it. If not, don't use it. There are other ways to achieve the reusability of the code. So before doing multiple inheritance, think at least 2 to 3 times whether you really need it. If yes, then only proceed ahead with multiple inheritance. So with this statement, let me proceed ahead and show you how multiple inheritance works and what we need to take care while using it. So we use inheritance for reusability. We want to reuse the code, right? So let's talk about an example where I'm creating a class called state. And in the init function, I'm just doing a small print and I'm creating a variable called state first. And in that variable, I'm printing or I'm assigning main state. Okay, and I'm creating a derived state called happy state. Okay, in the init function, I'm writing init of happy state, creating a variable. That all thing is fine. But in the normal inheritance in Python, unlike other programming languages, you have to explicitly call init of base class. It will not do it automatically for you. So in here, you have to call super init. Okay, when you call it and then you create the instance of a class, you get the init function of both happy state as well as state gets called. If you don't do it, the init function of base class will not get called. So this is important and simple to do in case of single inheritance. Now let's talk about multiple inheritance. So I have again created a class state, which is a replica of the earlier state class. Okay. At this moment of time, I'm also creating a class called event. So what it does, nothing. It also has an init function, creating a variable and printing something so that we know that this init is called. Okay. So I have created 2 classes, state and event. And I'm creating a happy state class, which is derived from both state as well as event. Okay. Now, as we know from the earlier example that we have to call base init to be able to get it called. So in here, I'm doing super init. Now, in this case, there are 2 super or 2 base classes, right? State and event. What will happen if I go ahead and create the instance of this happy state? What do you think? Let's see. It calls the init function, this is happy state, must be called, and then it calls the init of state, which is fine, but what happened to event? You know, ideally when you want to do multiple inheritance, you are deriving from 2 classes or more than 2 classes, you want to reuse the functionality available in those classes, right? But in this case, if I'm not able to call the init of event, how will I use it? That's the big question. And the even bigger thing is that if you do this, you will not get any error, right? There will not be any error message which says that you didn't call an init of event, right? Your code will just go ahead and run. So you have to be careful about understanding this and making sure that you know all the base init is called. Now you know there is a problem. We can't just do it with super. What if I call this super init 2 times? You might be thinking something like this, right? It will still call init of state. It will not go ahead and start calling event or next in line. Okay. So this is not gonna solve this problem. We have to do something more and something explicitly. So what we can do is that while creating happy state, we will print init of happy state, and in here we will explicitly call init of all the base. In here I'm calling init of state and init of event. Okay. Now if I go ahead and call happy state, I can see that init of both state and event is being called. Okay, so this is one way of solving the problem where I make sure that base class inits are being called. So if there are more than 2 base classes, we will have to write explicit init for each one of them. Now there is another way of doing it. Another way of doing it involves super keyword, right? The familiar keyword which we have used earlier. So in this case, what we will do is that we will create our happy state. In here, we will do super init, which is the normal super init, which will make sure that it calls state the first in line base init. But in the next case, we will have to call super by providing the state init and self init, but it will make sure that it will delegate the self call to the next in line. So this line will make sure that event init gets called, and if I create an instance of this class, you can see that state is also got called, event is also got called. I mean the init function of both these classes got called. So every time in this case, what you will have to do is that this is the first super, it will call the first in line the base class init. Next onwards, you will have to specify the state to the next init, so that next in line init gets called, and this is how the chain will work. Okay, now you might feel that calling it explicitly is easy and simple, maybe, but if you use super, you will be able to use dependency injection. So if you are not aware of dependency injection, I think of it as, if I replace this state and event class with mock classes, right? So in that case, super will be able to call those mock classes, but in here, I will not be able to call these mock classes. So most of the Python code uses this format. Okay. Now let's assume that what if we have 3 base classes? So I created a first class, second class, and third class. This is my combined class which inherits from first, second, and third. And to make sure that each and everyone's init gets called, what we need to do is that this is the first line, which we'll call first init. Then we will have to call first self init, which will delegate this to the second one. Then we will have to call super second self init, which will delegate it to the third one. And if we go ahead and create an instance, you can see that all 3 init function gets called, and that is something you need to take care of, because Python you need to make things explicit. Okay, now you know that we can do this and call all the init functions. Now this is a bit tedious and you have to remember everything, and you can easily miss out things. What if you don't want to do this and you want that as long as I'm calling this, all the base classes, no matter how many of them are there, should get called automatically? This can only be done if the base classes code you can change, okay, or if the base classes code is written as I'm going to show you now. So what happens that in the first class, I will do super init blindly, even in the second, even in the third. What I'm trying to do is that I'm doing this super init in all classes, and then if I am derived from first and second, and I just say super init, this thing will make sure that all the corresponding init functions gets called. And if I put in third over here, you can see that all the init functions of all the base classes are called. So this can happen, this can work only and only if this line is there in all the base classes from which you are deriving your class. Okay, now hold on, things doesn't finish over here. There is something more. I have already shown you this example, how to handle parameters, and this is very, very important because most of the time you are going to pass parameters in your init function, right? So let's see the way we are doing it earlier, right? So I'm creating the first, second, and third class, and the difference is that I'm passing a parameter called first, second, and third in the init. Okay, then how will I use the combine function to pass the parameters? So I have created class combine first and second just for simplicity purpose. I'm deriving it only from 2 classes, and in the init I'm getting the parameter first and second, and I'm doing super init. I'm calling first and second. How it will work? What do you think? Let's create the instance of this class. You can see there is some error, right? Because it says that init takes 2 positional argument but 3 were given. Remember, we are passing 2 parameters, first and second, and I'm doing super init. I'm calling first and second. How it will work? What do you think? Let's create the instance of this class, this example. How to handle parameters, and this is very, very important because most of the time you are going to pass parameters in your init function, right? So let's see the way we are doing it earlier, right? So I'm creating the first, second, and third class, and the difference is that I'm passing a parameter called first, second, and third in the init. Okay, then how will I use the combine function to pass the parameters? So I have created class combine first and second just for simplicity purpose. I am deriving it only from 2 classes, and in the init I am getting the parameter first and second, and I am doing super init. I am calling first and second. How it will work? What do you think? Let's create the instance of this class. You can see there is some error, right? Because it says that init takes 2 positional argument but 3 were given. Remember, we are passing 2 parameters in init function, but in here each init takes only 1 parameter, right? That's what this error is complaining about, which includes self anyway. So this cannot work. You cannot say that pass first to first super, pass second to second super. This cannot happen automatically, but there is a way around this, and most of the Python code which are using multiple inheritance and passing parameters, they are using this way. Okay, so the way which I am trying to tell you is using keyword arguments. So the way which we will be using to overcome this is quarks or keyword arguments. If you are not aware of args and quarks in Python, I will highly recommend you to see this video, this card video. I have explained what are args and quarks in Python and how you can make use of them. So what I am trying to do is that in the first class, I am taking the first parameter which I need to assign in this class, but I am also taking keyword arguments, which means that I can take any number of named arguments. Okay, same thing I'm doing.
So I think it's just putting keywords here. Show asterisk. See on Google how to say this.
asterisk,
Asterisk. Asterisk.
asterisk,
Asterisk. Still not working.
For second, same thing I'm doing for third one. Okay, so basically the parameter which I want to use, I'm using that, and I'm calling super and passing the keyword arguments. So if the keyword arguments are coming with this particular parameter, I'm using this parameter and passing the keyword arguments. Okay, same thing for third. Now let's see the class combined first and second. In the init, I'm saying self first and second, I'm representing it as f and s. In the super init, I'm creating a named argument or keyword argument. First equal to f, second equal to s, which means that in here, while creating the instance of the class, I am passing first and second. Okay, so let me create this class and I'm calling first and second. You can see that all three init function gets called, and c dot first will contain first, c dot second will contain second. Okay, even it doesn't matter if you change the second at the first place, the sequence doesn't matter. And even when I go ahead and do this, you can see that the output remains same because it is based on keyword argument. No matter second gets called first or first gets called first, it just used its own named argument and pass everything as keyword arguments. Okay, similarly we can use with all three base classes, and I have added one more parameter called first, second, third, and in the combined I am passing first, second, third, and I am creating a keyword argument over here. And if I do that, you can see that first all the init gets called, first will contain first, second will contain second, third will contain third. Okay, so this is the most appropriate way of using multiple inheritance with keyword arguments with super, so that you can get rid of any problems that might come because of multiple inheritance. So people, I hope now you totally understand why I have created one complete video on this specific init function with multiple inheritance. So that's all for
Maybe I should take the init and just put super. Yeah, but that's the problem, because then if I don't do this, it's probably gonna give me an error. Square object has no attribute with. Maybe they should put keywords here. Let's see if it. Okay. Yeah, it doesn't work like this.
Hey everybody, how's it going? In this series of videos, we'll be learning how to create and use classes within Python, and how object-oriented concepts are applied within the language. Now, there's a lot to cover when working with classes, so I'm going to break these up into several different videos. We'll cover the basics of creating and instantiating classes, we'll learn about inheritance, class and instance variables, static methods and class methods, and several other topics. So breaking these up in several videos will allow us to focus on specific topics in each video. So in this video, we'll be learning the basics of creating and instantiating simple classes. But first, why should we even use classes? Now, this isn't just specific to Python. You can see classes being used throughout most modern programming languages.
Maybe I shouldn't be using super. Let me see. This works. Square object has no attribute with. So maybe I should put soft not with. Invalid format specifier. This here. I'm not sure why it would be that, but maybe it's the 0 here. So I have two errors on the string. The diagonal is wrong. The string is wrong. So I think the diagonal is probably an easy one to fix. Just gonna write it down the way that they put it here. Yeah, that fixes. Set attributes. 6, 6. Expected string representation of rectangle after setting new values to. So the strings representation are wrong. I think the reason that I don't use super here is because I don't want to inherit from the parent class. But if at the same time, if I don't specify here, then throws an error. Try to change this, sure. See if it changes anything. Nice. So there's probably a problem here, this string. But now it doesn't work. So this one apparently is wrong. So I need to put a space here. Well, but there is a space there. Maybe I need to remove the space. Nice. Okay. Now just the errors on the string, I think. Set with requiring. So I guess this is not needed. And the other one can be any variable, probably. Now it's failing. But there's less one error less. Expect this string representation of square after setting width to be square side. Therefore. So here is new width. That. And it should be the other way around, I think. Yeah, so side. Nice. So two more. So they're both on the string now. I guess I can use Python tutor for this. Invalid format specifier. Maybe I can do it like this instead.
So why do we use args and keyword args in Python functions? That's what I want to answer in this one. So let's go ahead and take a look. Here's a really simple function, and if you run it, it's not surprising what's going to happen. Just hello world. So the key here is in any given function, if you pass in an argument now, what will happen with this call? If I run it, I get an error, and it's saying that it takes no arguments. So this is where args come in, or star args. This actually is a argument collector. It collects all of the positional arguments into this variable. And so now I can actually reuse that or print it out in this case. And now I can see something really cool. And I now see that it says the hello world, of course, the string originally, and then all of the arguments that are passing in. So if I pass in other positional arguments, I will see those things as well. So we can, oops, not that. We can see this in action. And what do you know? So it's now passing in all of those arguments. But of course, every once in a while, you pass in a keyword argument or key value pair, and you do something like this. So if I save that and run it, what's going to happen is we get a unexpected keyword argument key. So there's a couple ways on how we can handle this, of course. First way is by actually passing in key equals to none, or some sort of default value here. This would actually accept that single key. But what if I actually passed in another one like ABC123 as well and ran this one? Well, this time it's going to say that it got multiple values for argument key. That's a little strange here. Well, there's a couple reasons for this, and that's because of these positional arguments. This is actually in position 1, and then also this, right? So this is where things can get a little tricky if you're not actually designing your functions that well. But what we can also do is think of keyword arguments in a little bit of a different way by using a keyword argument collector with 2 stars and keyword args here. So now if I actually print out what the keyword arguments are, I am now getting all of my arguments correct, or at least collecting all of them. So again, if we were to do this a little bit differently, let's actually put it in positions now. I'm gonna get rid of all these extra ones. So if I actually set ABC equals to none here, what we should expect to see is, well, another error, that it's getting multiple values for keyword argument ABC. And that's because keyword arguments in this case can still be positional. So this isn't just positional arguments collector. This is just arguments that aren't keyword arguments after all of the positional arguments are done, right? So in other words, if I get rid of this one and now press in something like ABC and try and do a string like this, well, what's this error gonna look like? If we do that one, a non-keyword arg comes after a keyword arg. So this might seem like a bug, but it's actually a really nice thing to know that first off, all of the either positional arguments like this one, arg1, right? So this is a positional argument, it's not a keyword argument, but any argument that comes before args is gonna be in one of these, right? Unless there's keyword arguments in there as well. So if I get rid of this and reassociate these things, what we'll see is something rather interesting. So we go ahead and run that. And now we see it says hello world. There are no positional arguments, no collected positional arguments. And then there's just this dictionary of keyword arguments. So the only positional argument is going in here. It's no longer going inside of args. So of course, if I get rid of that, and now we'll go into hopefully what you think it goes into, which is just running into the args. Okay. So why do we actually use this? This is maybe starting to get a little complicated for you, but the reason that we use this is for functions that we don't fully understand everything that's going on in them, or those functions have many different features that you might not be aware of, or you just don't need at this time. So there's a lot of reasons to use args and keyword args. They're also a safety measure against running against errors, like we saw here, like something like this, right? Running against those kind of errors in cases where you might need that. I'll give you a really good example of this, and this is coming from Django and function-based views. And I'll actually leave those things. So let me go in here, and we define my random Django view. Okay, so often we'll get a request in here, and let's just say that that's all we're going to be returning. So I'll just print out the request. Okay, so what we want to do with this is we usually put it into a URL. That URL calls this request, and it passes the argument of request in here. And just in this case, I'll just print out what that argument is, like this. Okay, so then we go ahead and run this, and not surprising, we will get the request coming through here. But in your URL patterns, sometimes you'll have something like this, where it's a path, so my product and something like ID, right? So if you actually did that, what this path ends up translating to is ID equals to some ID. Okay, so hopefully right now you see that this is a potential challenge with how I defined this view. And so let's go ahead and run it again. And what you should see is an error, right? So my random Django view got an unexpected keyword argument ID. So that just means that this view is not ready to accept that keyword argument of ID, as we've already discussed. So a lot of times in Django views, you might see something like
In this lesson, I want to look at string formatting and functions. Don't worry if you don't know what that means, you will understand what it is very soon. So what I'd like to do is write a little program, because we haven't done an actual program yet. And what this program will do is it will ask you for your name, your full name, and then it will return the number of characters in your name. So we're going to create a variable called first name, and we're going to put that equal to a function called raw input. Now what this function does is it takes input from a user. So we will write a string in here. What is your first name? Question mark, colon. Raw input always takes string input. Actually, that doesn't really matter for the purposes of this program because we are taking in a string. But if you wanted to take in a number, for example, using raw input, the number that was entered would actually be a string, and you'd have to convert it to an integer. So, for example, if this was asking for a number as an input, you'd have to do that. But as we are simply asking for a string, then that's fine. So first name equals raw input. What is your first name?
Hmm. Let me see if this works. Can't multiply a sequence by no int of type set. It's not gonna work. I guess I can use this, right? Just so maybe I should take the n off slash n for new line. Now I should add somewhere, but this works. Okay, passes one more. So why is this not working? The other ones are working, but this is not working for some reason. If I do -1 here, it works. No, it should fail again. I think I watched someone else's videos for this one. No, I know what's wrong. It's because I'm not taking into account when it's a square. That's the problem. But how can I say that? Oh, I know. What I'm gonna do. Well, but then shouldn't make a difference because self width and self height are gonna be the same value. Let me see if it changes anything if I put line. I don't think it will. But yeah. So I'm getting 5 and is expecting true. When it's testing the square. So something is going on when I'm inheriting. Because it's giving me true as the side. And then for some reason I'm getting it 5. I don't think this is gonna solve anything, but it's worth trying. I'm also getting the double of the height. Yeah, that's the issue. So it has to be on the initialization thing. If I take this off, yeah. Let me run this on Python tutors if I understand. So sets all to 1. Size true. That's the issue. I'm not resetting the width and height. I set both of them. And then I'm calling these ones, yeah. This is probably not the best way to do it. It probably works. Nice. Okay, I'm gonna watch other people's solutions. Then I'm probably gonna come back later to do this probability calculator. So see you then.